Hello guys, and welcome back to this amazing channel. This is Abhinav. After a very long time, around after a break of 1 month, we are again back on our YouTube channel with all the video editorials of Leetcode, CodeChef, and Code Forces contest. And this time, I will try for the Ad Coder and Leetcode POTD also, right? So we are back after 1 month, and yeah, I was really busy with a lot of work from last 1 month, because of which I was not able to record these YouTube videos and all, right? So now finally we are back. Today the agenda of this video is to actually discuss about the bi-weekly contest 134. Okay, so we'll discuss all the 4 problems of this particular contest. Okay, so sorry, जो भी 4 problems हैं, we will discuss all of them. Okay, so let's discuss all the problems one by one. Actually, I was not able to participate in this particular contest at that particular time. I was a little busy with some work, but yeah, I have upsolved all the 4 problems and we will discuss all of them one by one. Amazing, great. So moving forward from the very first problem is alternating groups one. Let's discuss what the problem is. So the problem is not difficult. It's a basic problem. Problem says that you are having um a array, and the array contains it's an array of basically tiles where it can either contain red tile or a blue tile. So when the array value is 0, it represents a red tile. If array value is 1, it represents a blue tile, right? Now what you have to actually do is you have to actually find how many uh, alternative groups are there of size 3. What is alternative group? For example, the array is something like this. Okay, if you will see in this particular case, how many sub arrays are there of size 3? So here they are giving us size 3 only. So how many sub arrays are there of size 3 which contain alternative colors? Alternative means 101 or 010. So if you will see, this is not alternative, this is also not alternative, this is a alternative subarray, this is also alternative subarray, and guys, if you will see here, they are saying that it's a circle, means we will take a circular array, and that is why this is also a alternative subarray. So basically here there are three arrays that contain alternative numbers 0 1 0 1 1 0 1 0 and so on. ठीक है, 3 arrays हैं. अब how we will find this? That's a very basic technique. I will start from index number 0 till end, and for every index I will check index number I, index number I plus 1, and index number I plus 2. For being alternative, there are 2 cases, either 101 or 010. Basically, first and last means ith element and I plus 2th element. This should be same, and I plus 1th element should be different from these 2 elements. Okay, and that is what I'm checking here. The first thing is that ith element and I plus 2th element should be same, and ith element and I plus 1th element should not be same. And I'm also taking mod n here because it's a circular array, if I will say. It's a rotation there, right? So I hope that you have got the understanding of this particular video, this particular problem. If you talk about the time and space complexity, the time complexity that we have used is order of n only, and space complexity is order of 1, constant space. We have not taken any extra space here, right? So this is what the first problem called alternative groups is, right? I will not go to the second problem now. Now I will go to the third problem. Why third? Because third problem is just the second part of that. In this problem, there is a very major difference. So in the first problem, which is easy one, it is saying that you have to find number of subarrays of size 3. हमें 3 size की subarray बतानी, right? But now in this particular case, in this second version of this problem, here we have to tell sub arrays of size k, not size 3, of size k. तो हमें k size की subarray बतानी है instead of 3 size subarray. How we can do that? So here we'll use a little different technique to find it. First of all, guys, it's a circular array. Okay, so first of all, we have to handle the case of circular array. Let me give you an example. For example, if you will see this case, okay, this case. So this case contains an array of size, I think 7. Yes, 7. Okay. So this is an array of size 7. So this is the array 0, 1, 2, 3, 4, 5, 6. Okay. And the value of k is 6. ठीक है. So value of k क्या है? वो है 6. Now what we will do? Next, moving forward, what we have actually is we have to take all the subarrays of size 6 which are alternative. So you can see this is not alternative. No, it's not alternative. This is also not alternative. No, but if you will take, so see, if I will take like this is also not alternative. But this is actually a alternative subarray. If you will find it is 0, 1, 0, 1, 0, 1. So means last 4 elements and first 2 elements, because it's a circular way. Okay. And similarly, this is also alternative. You can see 1, 0, 1 and 0, 1, 0. Okay. But how can we handle this case of circularity? So guys, to handle this case of circularity, what happens is, see, first subarray will be like this. Okay. Then it will shift like this. Next, what will happen when it will shift? Like this, so one element of this will come here. Again, when it will shift forward, two elements of this will come. Again, when it will come forward, three elements of this will come. It will come forward, then four elements, and when it will come forward, finally 5 elements. Then it will stop. Like इसके बाद तो फिर पूरा फिर से ये हो जाएगा, right? So at max, the circularity will go up to 5 elements of A, which is actually k minus 1 elements from the top. So instead of going back in the circular manner, what we can do is we can actually add these first k minus 1 elements after this array. So this first k minus 1 elements, which are the 5 elements, I can add it as a part of this array. Because they are actually the part. Because in circular manner, they will come after it. So when I will add it, you will actually see that now we have all the subarrays of size k in continuity only. No need to handle that circular case. How? See. So this is the first subarray of size k. And moving forward, second, third, fourth, fifth, sixth, seventh. So just move a sliding window. Okay, great. So this is what we did. So you can see, I will explain the code all side by side. So you can see in the code what I did is that for the colors vector, I'm first were adding extra k minus 1 elements at the end of the colors array. Okay, at the end of the colors array. Now moving forward, what we will do? Now guys, we need a subarray which contains alternative values. Means a value should not be equal to its previous value. Every value should not be equal to its previous value and should not be equal to its next value. And whenever there will be an index, whenever there is an index arises, which is actually not equal, which is actually equal to its next index, means that index is failing the law of alternative group. So first of all, what I will do, I will create one index array of the same size. And this index array will store indexes which are violating the rule of alternative values. Violating rule means where a value I is equal to the value I plus 1. Means this value index I is violating the rule of alternative. क्योंकि I plus 1 के equal नहीं होनी चाहिए, but it is equal. So initially index will be 0. Now for all the indexes where the value is equal to the next index, I will increase the counter. So you can see here it's fine. So initially it will be 0. But you can see here for this index, you can see it is equal to its next index. So here it will become 1. Then for this also, it will become 1. And that's it. तो यहाँ पे सिर्फ 2 इंडेक्सेस हैं. There are only 2 indexes which are actually violating the rule of this what I say, this alternative groups. तो हम ये दोनों इंडेक्सेस नहीं ले सकते. ठीक है, हम ये नहीं ले सकते. अदरवाइज इफ यू विल सी, इतना पार्ट अगर आप देखो, it is alternative. This is also alternative. This is also alternative. And from this part only you will see that you will get your subarray. So एक आपकी ये देखो subarray बनेगी of size 6 और ये आपकी बनेगी. But कैसे? How? तो अब जब हमें पता चल गया, when we know that क्योंकि which are the indexes where the values were, now I will find the prefix sum for this index array. इस index array का I will find the prefix sum. And using this prefix sum we will get to know कि in a sub array क्या उस sub array में एक भी ऐसा इंडेक्स है which is violating the rule. How? To find a prefix sum. It will say 0 0 1 1 1 1 1 1 1 2 2 2. अब हम क्या करेंगे? I will start my I from 0 and I will move forward, and for every index from I to I plus k minus 2, basically from I to j, I से लेके j तक की हर एक सब एरे को चेक करेंगे क्या उस सब एरे में एक भी ऐसी इंडेक्स आ रही है which is actually violating. If there is an index which is violating, don't take that subarray. Else consider that subarray in the answer. For example, the first subarray will be from, so if you will index it, so it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so first I will be here and it will go up to here. Basically not up to here, up to here. Wait. So it will just go to I plus k, basically it will go up to 4 only. Why up to 4? Because if we are considering this index, it is like obviously considering the next index. क्यों? क्योंकि जब हम लोग मान लो इस index की value 1 हुई, तो this index value is 1 because it is equal to next index ना. Means we are considering both. ठीक है, तो basically हम लोग ऐसे consider कर रहे हैं. And this is a subarray of size 6. Okay, now we will see कि क्या इस subarray में जो sum है of this index is it 0, कैसे निकालेंगे? This 5 minus this 0. Sorry, इसकी इंडेक्स है, इसकी वैल्यू 1, इसकी वैल्यू 0, तो वो 0 नहीं है. मतलब कि इसके बीच में कहीं ना कहीं पे एक वॉलेटिंग इंडेक्स आई है which is here. Okay, now let's move forward. अब देखो यहाँ भी it's not 0, but when we will come here at this point, you can see that here also sum is 1, here also sum is 1. Means in between them there is no violating indexes. हाँ, मतलब बेसिकली हम इसको कंसिडर नहीं कर, सो बेसिक सॉरी इसमें नहीं होगा ऐसा बिकॉज वी डोंट सब्ट्रैक्ट दिस. सो वी हैव टू फाइंड द सम ऑफ अ सब एरे, वी टेक दिस वन एंड वी सब्ट्रैक्ट फ्रॉम दिस 0. अब व्हेन आई विल मूव फॉरवर्ड एट दिस पॉइंट, now finally you can see that in this subarray range there is no violating indexes and then your answer will be counted. So you can see that for every I and j I am saying find the difference from I to j, and if the difference is 0 means there is no violating index in that range, increase the counter and then return that value of c. Okay, so this is what we are doing here in this particular case guys. Okay, here also if you will see the time complexity that we are using is just order of n, but here I am actually using extra space also, again of order of n, right? Amazing. Now next is this maximum points after enemy battles. This is actually a greedy problem only, a basic greedy problem. Problem says that you are actually having some enemy energies and a current energy. Now what you can do two operations with the enemy energy. First of all, if your current energy is greater than the energy of an enemy, what you will do, you will decrease your current energy with that particular enemy energy and you will get 1 point. Okay, else what you will do, you will and if you have done this operation at least one, then you can do the second operation. वो क्या operation है? This operation will say that कि you will pick a unmarked enemy I and you will add the energy of that enemy into your current energy. So you can pick any enemy which is unmarked, means which is not taken previously, and you can consider it in your current energy, and then you will make that I marked, means now you cannot take that enemy, right? So do guys, first of all, and you have to find the maximum number of points, right? So if you will see in this particular point, which enemy you should take so that your less energy is gone and you also get a 1 point. Obviously we'll take the enemy of the lowest energy, ठीक है. तो for example एक better example ले लेते हैं. For example your enemy array is enemy array is like this: 5 1 2 6 3, and your current energy is let's say 5, ठीक है. तो फर्स्ट ऑफ ऑल आप क्या करोगे, आप इसको सॉल्ट कर लो. सॉल्ट दिस एनिमी अरे, इट विल बिकम 1 2 3 5 6. अब यू विल किल द जीरोथ एनिमी अंटिल यू हैव द पावर ऑफ इट. फॉर एग्जाम्पल तो लेट्स से 0, इसको 0 1 हटा देते हैं, लेट्स मेक इट 2, ठीक है. तो यू हैव करंट पावर 5. तो विद दिस पावर 5 हाउ मेनी एनिमीज यू कैन किल ऑफ दिस, लाइक द स्मॉलेस्ट एनिमी. कितने एनिमी आप किल कर सकते हो. तो सिंपल लॉजिक क्या हुआ, सिंपल इज सी डिवाइड बाय 2 वट एवर द वैल्यू इज. तो आप देखो कि 5/2 इज 2 मीन्स यू कैन किल 2 एनिमीज ऑफ दिस साइज 2. तो आप क्या करोगे, you will finally kill these 2 enemies of 2. Your point or your answer will be 2. But now after deleting that your remaining c is 1. तो आप देखो यहाँ पर क्या कर रहे हैं कि we are first of all sorting the enemy. अच्छा, first of all if the enemy 0 is less than if the value of the smallest enemy is even greater than your current energy, means you cannot even kill a single enemy, then you will just return 0. Else what you will do, you will start from index number 0. Okay, start at index number 0, and what you will do, you will say if the value of the smallest enemy is less than equal to your current energy, means you can use your current energy to kill that enemy. So what you will do, you will first of all see how many enemies you can kill, which is actually current energy divided by the energy of the enemy, right? That much number of enemies you can kill, and that will be added in your answer. Profit में add हो जाएगा, and remaining energy you will have. But in case आपकी एनर्जी कम पड़ गई, फॉर एग्जाम्पल अब आप देखो तो योर एनर्जी इज 1 only. Now when your energy is less, then you will increase your j, means decrease your j. So your j is going from the back actually. तो इसलिए आपका j यहाँ पर होगा. इन दिस केस आप क्या करोगे, आप ये एनर्जी ऐड कर दोगे, मतलब यहाँ पर है आपका j. This 6 will be added in the c, and then this 7 will be used to again have this 2. तो कितने आएंगे इससे, फिर 3 आ जाएंगे, और फिर इसकी वैल्यू 1 बची. अब ये 5 आ जाएगा, 6 से अगेन 3 आ जाएंगे, अभी 0 बचा, देन 3 विल कम. तो दिस इज हाउ, फिर इससे 1 आ गया, तो फाइनली अब यू हैव 9. तो दिस इज हाउ, फर्स्ट ऑफ ऑल you have the current whatever you have. Now using that current you will try to kill your first initial enemy. You will always try to kill the first initial enemy, okay, and one by one. So basically you can also do one thing, you can first find the sum, like sum of all the other elements apart from the first index, and then you can simply divide also. But that will take problem in some of the cases. So this is better, a greedy approach, which is intuitive also, right? I hope you have got the understanding of this. If you talk about the time and space complexity, we have not taken any extra space, so space complexity is constant. But time complexity will be n log n. We are actually sorting it, so it's n log n. Okay, cool guys. Now moving forward to the last question of this particular video. Last question क्या है? Let's discuss that. It is also a basic problem statement, is very basic. You have to find number of sub arrays with and equal to k. So you have a array and you have a value k. You have to find number of sub array who has its value k, which has its value k. अब how we can find that, हम कैसे निकालेंगे उसे. तो देखो guys, first of all we have used a very good logic here. The thing is that, see, देखो हमने एक फंक्शन लिखा है, ये फंक्शन क्या फाइंड करता है, this function actually finds, using the sliding window technique, it actually finds number of sub array which has and value at least k. At least k means number of sub array which has and value k, or it can also have and value more than k. So it finds that much number of sub array which has and value of k or more than k, or more than k. And how we can find this type of sub array, कैसे निकाल सकते हैं. Let's first implement this function. तो function क्या है, तो basically what now problem is little different. Now we are not finding number of subarray having and equal to k. No, let's change it. I will tell you why we are doing that. Now our question is that we will find a number of subarrays. We will find number of subarrays whose and value is greater than equal to k. जिनकी and value greater than equal to k. अब how we can find that? कैसे निकालेंगे? So we have a technique for it. क्या technique है? So for example, कि we have an array like this. Let's say 3, 1, 5, 2, 3, 4. Okay. This is our array. Okay. Up first of all, see, when can we say that the elements in an array contain and value k? How we can say that? Or basically at least k, mean and value not equal to k, but yeah, at least k means it can also be greater than equal to k. For example, if I'm saying, okay, if let's say our k is 3, okay, and let's say we are taking this as our subarray, can we say that the elements of subarray has the and value 3? How we can say that? There's a very basic method of checking that. What? The method is that first of all, you'll find how many set bits are there in this k. So you can see in this k, the value of k is 0, 1, 1. So there are two set bits. Now let's find the set bits of these three numbers, because guys, the set bits of this k should also be set in all the elements of this array. That then only you can get the final and value at least k or greater than k. तो बड़ी भी हो सकती है. It can also be greater, but at least k it will be. So my logic is that the number of bits, and not just the number of bits, the bits, the exact bits which are set in k, those bits should also be set in all the elements of the subarray if you want its and greater than equal to k. Let's find this. So 5 का क्या होता है? 101. 2 का 010. 3 का 011. So this will not give you and value greater than equal to k. Why? Because यहाँ पे आप देखो कि here we have two requirements. These both the bits should be set, but here it's not set. Here it is not set, right? But in the same case, let's say we have something like this. Let's say we have array like this. Now you can see this will work. If your k is 3, it needs 0, 1, 1, and if you will see here, it is 101. 110, 1011 and 111. This will give you a and value of at least k. ठीक है? तो सबसे पहले तो आप जो सबअरे कंसीडर कर रहे हो, so the number of bits in that particular subarray, that number of bits should be set in k also. They can more set bits, so इससे ज़्यादा हो सकते हैं. जैसे कि हमें ये दोनों bit set चाहिए, हमें ये दोनों एक बचाओ, I did one mistake, ये नहीं हो सकता है. Okay, so this sorry, this is also not possible. तो मे बी इसकी जगह पे हम 8 like 15 ले लेते हैं, तो 15 के लिए हो जाएगा. आई डिड वन मिस्टेक, तो 1 1 1. तो आप देखो कि यहाँ भी दोनों, तो इस दोनों जो बिट्स हैं ये इन तीनों में सेट है. तो इफ द बिट्स विच आर सेट इन के, those all the bits should also be set in all the numbers of the subarray, then only that subarray will give you a size, a sum of greater than equal to k. And not just that subarray, every subarray of that subarray will also give. So because 15 3 7 is having an end value of 3, at least 3, so 15 3 will also have 15 like 3 7 will also have, and just 15, just 3 and just 7 will also have. तो अगर 15 3 7 this whole array is having at least value k, तो उन सबके separate जो सब उनमें भी k होगी. क्यों? Because those all the values are containing two set bits जो इसमें भी है, वो सारी वैल्यू आ रही हैं. तो सारी बीट्स की जो सब एरर्स हैं वो आएंगी कहाँ पे? वो सारी का एटलीस्ट जो होगा एंड वो के होगा, एटलीस्ट उनका एंड के होगा. ठीक है? और हमें ऐसी सारी सब एरर्स बतानी है. वी हैव टू टेल ऑल द सब एरर्स ऑफ दैट. और कितनी सब एरर्स होंगी, कितनी सब, अच्छा एक पॉइंट और है. तो बेसिकली व्हेन वी हैव आर, सो हम लोग ये अलग अलग साइज के लिए लेंगे एक्चुअली में. वी विल नॉट टेक सब एरेज ऑफ डिफरेंट साइज. मतलब हम बेसिकली इस तरीके से लेंगे दैट इफ वी हैव अ सब एरे लाइक दिस ऑफ साइज लाइक 15 3 7, तो इट कैन बी जस्ट 15 3 7 ऑल्सो. it can be just 15,3 also and can be 15 also. हम ये तीनों केसेस यहाँ पे हैंडल कर लेंगे बिकॉज नेक्स्ट केस में हम ऑलरेडी नेक्स्ट यहाँ पर जाने वाले हैं. हम अपने एल को इंक्रीज करेंगे वाइल ये केस ट्रू हो. तो क्योंकि हमें सारे पॉसिबल कॉम्बिनेशन देख रहे हैं राइट. तो हम क्या कर रहे हैं यहाँ पे, इफ यू विल सी कि हम लोग क्या कर रहे हैं, वी आर फर्स्ट ऑफ ऑल गोइंग थ्रू ऑल द नोट. एल हमारा इनिशियली 0 है और हमारा आर आइट्रेट करने वाला है. तो इनिशियली हम लोग क्या कर रहे हैं कि इफ दिस इज आवर एरे, लेट मी गो बैक. Initially my L is here and my R will also start from here. And in the temp, it will store okay, how many bits are set. So you can see for every bit from 0 to 32, if it is set in R, I'm increasing the temp. Now, while R minus L plus 1 is greater than 0, means while the length of your window is greater than 0 and calculate temp comma size of the window is less than k. Basically ये calculate क्या करेगा, this function will tell the and value of this. और जब तक and value इस रेंज की k से छोटी है, अगर and value k से छोटी है तो आपको l को इंक्रीज करना पड़ेगा, आपको कुछ एलिमेंट्स हटाने पड़ेंगे. ऑब्वियसली अगर मान लो एंड वैल्यू, अगर मान लो यहाँ तक एंड वैल्यू थी, अब यहाँ पे ये बढ़ गया, एंड वैल्यू छोटी होगी तो आपको कुछ एलिमेंट हटाने पड़ेंगे इनिशियली सो दैट एंड वैल्यू फिर से उतनी आ जाए. एंड व्हेन यू आर रिमूविंग एलिमेंट एल, आपको उसके बिट्स भी टर्म से हटाने पड़ेंगे. एंड व्हाट दिस कैलकुलेट फंक्शन विल डू, कैलकुलेट फंक्शन विल सिंपली टेक दिस टेम्प एंड फॉर दिस टेम्प इट विल अगेन चेक फॉर ऑल द इंडेक्सेस फ्रॉम 0 to 32 कि जितने भी इंडेक्सेस हैं उनमें से कौन से इंडेक्सेस हैं जो इन सब में प्रेजेंट है, क्योंकि टेम्प में कितने वैल्यूज हैं, W इंडेक्सेस हैं. तो जो बिट सारे W नंबर्स में ट्रू होगी वो हमारा बिट हमारे एंड में भी आ जाएगी. और फाइनली अगर हमारा आंसर जो एंड है वो के से छोटा है तो हमें हैंड चाहिए के से बड़ा. जब तक while the and value of our window is less than k, while the and value of our window is less than k, we will increase our L and we will have that window. And once we have the window from L to R, जब हमें पता होगा कि हाँ this window from L to R is having and value of greater than equal to k, we will actually add that in the answer. Okay, the number of other subarrays also. And now as I told you, we changed the question, right? Our question was not number of subarray greater than equal to k. Our question is number of subarray equal to k. So what I will do, I will first find number of subarray having at least k minus number of subarray having at least k plus 1. So basically this will contain all the subarrays having and value k or more than k. This will contain all the subarrays of and value k plus 1 or more than that. So when you subtract it, it will contain number of subarrays having and value equal to k, right? So guys, this is the logic of this particular problem. It is little complex, right? It is little complex. I understand. I completely understand. But still, if you have any doubt, I tried to explain it. But still, if you have any doubt, you can join the Telegram channel. You can ask it out there, or you can also ask in the comment section, and I will respond to it, right? So I hope that guys you have enjoyed this particular video. You have got the understanding of these problems. We have started this videos back after a long time, and we will continue this later. Thank you for watching for the video. See you in the next video.